All right, I'm doing my lesson here on Introduction to Sequences and Series, where I'm going to have them um, doing some discovery stuff. To start off with, I plan on going through problem solving, what it takes to solve a problem, the understanding of the problem, consider the resources, devise a plan, carry out the plan, and be aware of your progress, along with looking back. Um, Also, I'm going to look at the strategies here, and you can see there's the table there of some different strategies. Of course, with sequence, there'll be some parts that will be more involved than others. So to start off, I'm going to give them a sequence right here. I'm going to have, this is a pretty normal problem here with the auditorium, 60 seats in the first row, 68 in the second, so on and so forth. I'm going to ask them to post what the number of seats in the 20th row are, and to give me any tries that they didn't work. This is that idea of mistakes. I just have found this week in class that the word mistake doesn't go so well when it comes to posting. They don't like to share, but I switched my vocabulary to tries, and I had students then willing to put what they had up. So I'm going to be using the term tries as I go through this. After that one, I'm going to just give them this one. You can see there's 4 terms. I'm going to be asking them to find the 5th and the 8th, and then a formula to predict the nth. I'm asking them to look back at any of these 4, so it shouldn't matter, and make sure that the formula works. And if it doesn't, well, there's a try, so then they'll need to try again. My plan is to repeat this a few times. As you can see, here's another one, same thing. A 4th term, 6th term, and then a formula. Once they get the formula, to look back, see if it works by plugging in a 1 or a 2 or a 3, because they know what the answers are. They're right there. And then post any tries they've got. Here's another one. By this point, I'm expecting them to be getting pretty proficient at coming up with their formula, so we can start to talk about what it takes to make a formula. And I'll be discussing that, in this type of sequence, what are the variables? Now, we know that this is an arithmetic sequence as teachers, and so the variables, where did you start with and how much you adding every time? But I want them to verbalize that, to put that out there. So then I'll go through and say, okay, so here's a sequence, and this is just obviously numeric, and we can follow that every time it's what you started with plus how much are you adding every time, to get to the formula that is typically put into textbooks. I'd like to talk with them at this point about just notation, that the formulas they've been coming up with, I'm assuming it will be very, very similar, and that for the most part, it should just be a matter of notation, and that as people studying mathematics, we need to be okay with using generalized notation that other people, when we communicate, can actually understand as well. So we're all using the same quote-unquote vocabulary, so same notation. After that, I'm going to jump over to series and explain to them that a series is just the sum of a sequence. And in this case, of course, an arithmetic one. And I'm going to start with this problem here, asking them to find the sum. I do plan on asking them to find this, though, in a different way other than starting at the left and going to the right. Come up with some other way that they could add this together. And then I'll be asking them to discuss it, to post it, and then we could just look at what they came up with. Of course, the answer is 55. And then I'm going to give them this one, from 1 all the way to 100, which is probably going to be problematic for some of the methods they may have used the first time. But it'll get them thinking about, when they've got big numbers, how they could possibly put them together. And this will actually be towards the end of my first day of the class. And then I'm going to give them an assignment to work on. This assignment is going to ask them to find all of the seats in those first 20 rows. So it goes back to the first problem I gave them. I am going to ask them to do some reflective stuff here. I'm going to ask them if they feel that they were better at solving the problems by the end of the day than at the beginning. As they went on, did it get better? I want them to see, reflect on that and to explain. I want them to think about whether their effort plays a part in how they respond to the question above. Is effort part of this? Trying to look at that idea of control. And I want them to discuss, again, a reflective question here, discuss difficulties that they encountered as they went to find formulas. And then, of course, to bring this back on the next day. And the second day, I plan on going into the story that some of you are probably familiar with, how Carl Gauss had the same uh, problem given to him, add up from 1 to 100, and how he did that with his method. And we can compare then to the method they came up with for the seats in the auditorium. And from there, I will give them then the formula that goes with that Gauss's method, the one that many people are familiar with. And again, this is going to be some notation, just explain the notation, what the parts are. But by then, they should have an idea already of what's entailed with the formula, what they would need for the formula through their activities. I would go through, there is a second formula, but it's really just a derivation of that first one. And then I'm going to introduce them to a geometric. I'm not going to call it geometric right away. I'm going to say just a different one. And then go through the same process again. Predict the fifth, predict the sixth, come up with a formula, look back, see if the formula works, and put up any tries that didn't work. I'm going to ask them if they believe they're capable, because this will be a little bit harder to come up with. If they believe they're capable of coming up with a formula for this particular pattern. After that, I'm just going to go through similar to the first day. It's just these are going to be geometric ones, trying those, coming up with formulas, looking back, putting tries up that didn't work, recognizing the mistakes, and maybe we can tweak some of the mistakes to make them work. I think there'll be some great discussions in this activity for that. And then I'm going to just start to have them differentiate between, is it a geometric or is it an arithmetic sequence? Just picking out which would be the correct one. And in a case of geometric, what would be the variables? What are the variables that we need to know? Just like we did with the arithmetic. What are the variables that we got to know? From that, we can give a generalized formula. I'm assuming they'll have something. We'll put something together in class. I know I'm talking fast here, but we'll be discussing it in class, and then I'll go to this one here, just kind of the generic version with the notation that's normally used. We can run through just the notation quick with them. And then I'll be giving them an assignment for the second day. So I actually have two different days lessons here, one on arithmetic and one on geometric. Second day, come up with the sum. I have noticed I have not given them a formula for that yet. So this is going to be problem solving. Question 2, do you believe that even if you come up to a wall that you can somehow find that formula? And part 3, come up with a formula for finding the sum. So first part, do a specific one, then a generic one in between, talking about their belief, if they believe it's possible to do that or not. And that is the assignments those are the lessons. It's really just one big lesson, but I know it's going to take me a couple of days. I'm talking fast, where with the class I'll be giving them time to do a lot of work in between. So